Hi everyone, and welcome to Chapter 3. So, you're going to see in this video just a couple minutes of talking about what Chapter 3 is, hitting the due dates and everything. But the first thing to talk to is we're actually going to break Chapter 3 into two parts. So, Part 1 will be included on the next exam, right here. So, the next exam will include Chapter 2, and then Part 1 of Chapter 3, which includes sections 3.1, 3.2, and 3.3. You'll notice that section 3.4 and 3.5 we will get to after the exam. So the exam covers Chapter 2 and the first three sections of Chapter 3, the only sections you'll actually find in here. Okay, so coming off from that, you can see we have the exam 2, a written homework, number 4. You have quizzes on the 8th and 9th. These are the Sundays. This is all March. And up here, we're getting into April just a little bit. And then you have 2 computer homeworks that are due right here on section 3.1 and 3.2. So the way we'll do it is we will be doing, the week of the 15th, we were going to be doing chapter 3, sections 3.1 and 3.2. We're going to package them together. And then we're going to be doing section 3 in the next week. And then you'll have your exam the week after. So everything else is pretty similar. Here's your written homework. You can check out the problems. There's 2 weekly activities you're going to have to hand in, just like always. And then you can go into these folders to see the computer homeworks and the readings. Okay. For week 9, just to kind of give you an idea, just to show you, although we've seen this before, right? We've got a weekly activity that's right here. This one is a little special. There's actually 2 Google forms on this one that you have to fill out. Okay, so I could just kind of quickly open that up. So there's some parts to do here, and then a Google form, and then we're going to do stuff in class off of part 1, and then you get to part 3, and this is still for you to do before class. So there's a second Google form for you to do before class. Just a short survey, and in this one, you're going to be counting some letters and words, and you're going to be telling me what you get. Okay? So, not too bad. It's not really a lot. There's a couple steps to do, but it's really not too bad. So, make sure that those are done by Thursday at midnight. Right? So, I have time to get all the data together. The earlier you do it, though, the nicer it is for me and then my other sections that aren't on Monday, Friday. So, they meet earlier, so if you can get the data in earlier by filling out the Google forms, you give them more to work with. It's fine, though. You can do it by Thursday night. You may just want to, as soon as you see this, you might just want to start working on it, just so you can get it out and get it done and not forget. Okay, so that's that. Kind of the same breakdown as always. And then what I wanted to do was also discuss just a little bit what is going to be in these next 3 sections. Just a very short amount. In sections 3.3 and 3.1, 3.1 and 3.2, we're actually going to take a short break from the work we've been doing. I promise we're going to get right back to it. Null hypotheses, p-values, all that. It's not going anywhere. It's just taking a little break. So this is going to be a break from the more technical side of the class, and we're going to talk a lot more about the process of, 1, gathering a sample. So we're going to talk about this, like how do I actually get a sample? So this is what 3.1 is, right? I keep saying, oh, I have a sample now, just out of thin air. Well, we're going to talk about the right way to do that, the best way to do that. And it's not always possible to do the best way, but we're going to talk about what can happen when you don't and things you need to be thinking about. So that's 3.1. How do I actually take a sample and do it the right way? Then section 3.2 is once you've already gotten the sample, okay, then this idea is, let's say I have a couple variables that I'm interested in. So I have 2 variables, okay. I need to be able to talk about differences between the variables or connections between them. So this in 3.2 gives us a start on what's the language to talk about connections between variables. So not just two variables, but connections here. More specifically, so connections here, we're going to talk about causation, one variable causing another to change. So cause, this is a very important idea, right? You're in science, you're doing experiments, you're looking for cause relationships often, versus we're going to talk about another idea called association. And so we're going to talk about this idea of having two, I keep saying variables, you can just say things. Two things that we see a connection between in our data, okay? And then we're going to talk about, okay, well, I see that, but how can I actually use statistics to show that connection between two things is a causal connection? Like that thing that's connecting them is that one variable is actually causing change in the other. Because that's a possibility, but it's also a possibility that it's a coincidental connection, that the connection is, or that the connection between them is not direct, it's indirect. There is something else behind the scenes we're not thinking about that is actually causing two variables or things to seem directly connected. When they're not, they're really connected by something else. So that's important. You should think about many studies I'm sure you've seen that have the words in them, blank causes blank. Right? We're going to talk about when it's appropriate to actually use that versus just saying blank is connected with blank. That's a very different thing to say, and we need to know when we are allowed to say one versus the other. So those both have no connection directly for us to p-values and hypothesis tests and all that. This is really us now taking a break and saying, okay, we can do hypothesis testing, p-values, standardized statistics. We can do all that, right? We're learning about it still, we're practicing, but we can do it. Now, we need to talk about how to set things up so that we are maximizing that work that we just did. Like it actually means something. Because we could just apply statistics willy-nilly, all of these things we've done to any old situation, and the statistics, logic, and ideas might be right, but if you start with faulty information, if the data you gather is not, I'll just say good, and we'll talk about what that means, but if it doesn't address the things you want it to address or do what you want it to do or come from the population or group you were trying to actually learn about, then it's really not worth as much as it can be. So this is us learning how do we set things up right so that we can do the statistics, and then the conclusions and everything we get, those conclusions have something behind them. How do we make those conclusions in a way that shows causation between variables? How do we set things up so that those conclusions that we're getting from our sample, we actually feel confident we can apply back to the population? We've been taking that for granted now, that you can just, reject the null. Okay, that's true for the population too then, or at least I think it's true for the population. Not so fast. We have to talk about how and when that's possible to do. So, nice little break from the number crunching piece of this, and it's just a lot of examples, kind of thinking through stuff. So that's 3.1 and 3.2. Nice little break there, and then 3.3 is called the theory-based approach to hypothesis testing, or just the theory section. So this section's pretty neat. We go back to our p-values, our standardized statistic, our kind of problems. And what we're going to do in this section is we're going to ditch simulation for a bit, and we're going to go old school here, and we're going to use just math theory to find p-values, to find standardized statistics in these situations. And we're going to see that it's pretty crazy, but often, not always, we'll have to talk about when it doesn't work, but often we can use this theoretical knowledge of what should happen to predict our simulated distribution, our pictures we've been simulating. We can actually, with just a small amount of information from the problem, Set that picture up. Know what that shape will be. Know where the middle will be. Know what the spread will be of that shape. All those things, we click the button, all those calculations the computer's doing with the dots, we can actually sometimes predict those numbers, that shape, everything we want about it. And we can use that predicted simulation. So it's not really one, it's predicted. It's a I think this is what's going to happen based on the theory. We can use that instead to find p-values and do all of our work. It's pretty nuts. It's really cool that it works this way. Now, the simulation method is more flexible, which is why we focus so much on it. But this is just a really nice way to kind of wrap everything together and show a little history on how things are done, and it's still done this way, to use this theory approach, and that is more appropriate at times. But in general, the simulation approach is a very good approach that's very flexible and really works well. But you're going to get to see, how it was done many moons ago. And in this section, we will have some generalizations to types of statistics and things you'll do later as well, if you keep going in statistics. So, pretty cool section. But again, it's not too much new. We're still doing p-values, same conclusions, hypotheses look the same. We're going to do a bunch of the same problems. It's just we're going to do p-values, standardized statistics, without a simulation, by predicting what the simulation would have looked like using theory. So it's a pretty cool section. And that's it. That's part one. So first two sections, let's set ourselves up so we can actually use the statistics we're going to do, and it's worth something, it's valuable to answer the questions we want. And then 3, let's go back in time a bit to see how this was done using theory, and still because it's done that way at times as well, just to kind of really bring everything back together. So that's it. Those are the sections. Start your reading, get through, go look at the examples, check out the weekly activity, and we will get going on that in class.